Hello, I'm Sri Lalita and I will be explaining about the naive Bayes example. So here we have three attributes, that is weather, temperature and humidity. So for the weather we have sunny, overcast and rain. Here for temperature we have hot, mild, cool, and for humidity we have high and normal humidity. So the probability of play being yes is equal to 6 by 9 and the probability of play is equal to no is 3 by 9. Let's look at some further example. From the above data, now we will be doing the testing, that is predicting a label for a new instance. X is equal to weather, that is being sunny, and temperature being cool, humidity is high. The probability from the learning phase is the probability for the weather being sunny and playing equal to yes is 1 by 6. For temperature being cool and play being yes is 2 by 6. And the humidity equal to high and play equal to yes is 3 by 6. And the same goes for the other probabilities for weather and play, and the probability for temperature and play, and humidity and play. For no, play being no and here play being yes. So the probability of yes for x is will be the probability of sunny being yes and the probability of cool being yes and the probability of high being yes and the probability multiplied into the probability of play being yes, that is 0.0185. And for the probability of no for an event x, that is the weather being sunny, the temperature being cool and the humidity being high, the probability is 0.0740. So as the probability of no of x is greater than the probability of yes of the event x, the predicted label will be a no.
I'm Mukesh Kumar. I'm going to explain text classification using naive Bayes and some an example with training set consisting of 4 questions and statements. The naive Bayes classifier is a simple classifier that classifies based on probabilities of events. It is applied commonly to text classification. Though it is a simple algorithm, it performs well in many text classification problems. Other pros include less training time and less training data, that is less CPU and memory consumption. As with any machine learning model, we need to have an existing set of examples, that is training set, for each category classification called classes. Let us consider sentence classification to classify a sentence to either question or statement. In this case, there are two classes, question and statement. With the training set, we can train a naive Bayes classifier which can use to automatically categorize a new sentence. For example, our training set will consist of 4 questions and statements. We need to find out if a new sentence say, what is the price of the book is a question or not. We will use Bayes-Naive theorem to solve this. Bayes theorem is given here. We need to find out what is the probability of class question given the new sentence and the probability of class statement. Here we need to find out which class higher has a bigger probability for the new sentence. That is, we need to find out which of the below is bigger. Probability of statement with respect to what is the price of the book, or probability of question with respect to what is the price of the book is given here. For example, it can be taken as probability of what is the price of the book with respect to statement multiplied by probability of statement with respect to probability of what is the price of the book. Since the denominator for both the equations is same, we can ignore the denominator and have to find out the values of the numerator. So we have 4 by 8, that is 4 occurrences for all occurrences, that is A, we get the probability of 0.5. The problem here is the new sentence need not to have to appear in the class within the training set. In that case, the probability is 0. That is, since what is the price of the book did not appear in any of the classes in the training set, the probability is 0. So let us split the sentence to words and assume that every word in the sentence is independent of one another. That is, we no longer looking at entire sentence but rather at individual words. In that case, The probability of word with respect to class is the number of times the word appears in that class to the total number of words in that class. So this is the example of text classification using naive Bayes. Next is applications of text classification. Thank you.
So some applications of text classification include spam classification of emails as spam or legit, sentiment analysis where you can detect the mood of the user based on the text that they've written, topic classification where given an article it can tell you what topic it's about, and finally identifying the demographic of the person based on the writing style. So the steps involved in naive Bayes text classification is to first identify the classes, the generated classes. Second one is to compute the term document matrix for each individual class by tokenizing. Tokenizing is just replacing all the strings with a numerical value, and then computing the frequency of each term, and finally compute the probability of a term occurring and its classification result using naive Bayes. So a question that can be asked is, why is tokenization performed in the first place? So most machine learning models, including naive Bayes, take numerical vectors as their features. But when you consider text is just a random string with variable length, and those are just letters which can be really considered to be numerical values. So the string that you end up with, it has to be converted into a number before the model can be built. So that's where tokenization comes in. Tokenization assigns each individual token. A token can be a word, a letter, or a phrase, a set of phrases, similar phrases. Tokenization converts each token, lexical token, into a number, which is then fed into the algorithm.
So far, we've seen how naive Bayes algorithm works, its use in text classification, and its applications. To conclude, naive Bayes algorithm has an edge over other classification algorithms because of its ability to take into account a large feature set. The simplicity of naive Bayes algorithm makes it easy to use and does not require parameter tuning. It does not overfit the data very often. Naive Bayes algorithm can handle a large amount of data, and the model training time and prediction time is very fast compared to the data it's fed. Naive Bayes algorithm is used in a variety of real-world applications, including sales, analytics, telecom, and optical character recognition applications. Thank you.